Good morning. Uh, we will explain about friction stir welding. Uh, right here, we have a tool for friction stir welding, and we will explain. Let me introduce myself. My name is Ishak, and my partner.
Muhammad Rizky Kajola Rifin.
We will collaboration to explain it, the wall of friction stir welding. Hope you understand.
Invented 1991, friction stir welding was developed and is patented by Welding Institute. The first friction stir welding is a solid-state joining process, but the metal is not melt. It uses a third body tool to join to facing surface. Heat is generated between a tool and material, which leads to near a very soft region, the friction stir welding. The first purpose-built and commercial available friction stir welding was produced by ISEP Cutting and Welding Technology at their manufacturing plant. Part of friction stir welding. First, welding tools. Welding tools is a critical part of friction stir welding. It always rotates uh, which RPM standard of weld. Second, probe. Probe is part of welding tool. It always rotates based on welding tools, and it can be friction between a material and tool. Last, probe. Probe. Probe is function of probe is to measure uh, depth of material to get a good melting point.
Now I will explain to you the principle of the friction stir welding. Splicing material without filler metal by using friction stir welding is often done. Friction stir welding is modern welding process that is not using filler metal like the other welding methods. Friction stir welding is generally apply the principle of friction by rotation tool. Now, this is the probe. Probe is transversely fed at a constant rate into the butt joint. This probe is shorter than the weld depth required, with the tool shoulder riding on the top the work surface. Frictional heat is generated between the weld-resistant welding components and the work pieces, and this heat, along with that, is generated between the mechanical process and the adiabatic heat. During welding process, friction stir welding, there is a microstructure during welding process. The microstructure can be broken up into several parts. First, the unaffected zone. The unaffected zone is the part that is not exposed by the heat, and heat affected zone, or HAZ, is common to all welding process. And the thermomechanically affected zone, or TMAZ, occurs on either side of the stir zone. And the last is the weld nugget. The weld nugget is the part of the thermomechanically affected zone, and you can look the part at the picture.
Advantages and limitations of friction stir welding. First, good mechanical properties in as weld condition. Second, can improve safety due to the absence of toxic. Third, easily automated by simple mill machine. And last, low environmental impact. Tool. Design of tool is a critical part as a good tool. It can improve the good quality of weld. Tool to it and plunge depth. The plunge depth is defined as the depth of the lowest point of solder below the surface on the weld plate, and has been found to be a critical parameter for ensuring weld quality.
Now I will explain to you the forces that will act on the tool during friction stir welding. A downward force is necessary to maintain the tool at or below the work surface, and the lateral force may act perpendicular to the tool direction. And there is a torque. This is the torque. Torque is required to rotation the tool. To prevent the tool fracture, the weld cycle is so modified so the forces that will act on the tool as low as possible. Alright, the welding cycle can be broken up into several stages. There is dwell, transient heat, pseudo-steady state, and post-steady state. Heat generation during friction stir welding arises from two main sources. There is friction of the tool shoulder and the deformation of the material around the tool. The contact condition under the tool shoulder can be described by sliding friction and sticking friction. Mathematical approximation for the total heat of the shoulder have been developed by both sliding friction and sticking friction models, whereas P is interface pressure, omega is angular velocity, and this is the radius of the shoulder, and this is the radius of the pin. And if we use this mathematical approximation, we have the torque to determine the total heat of the shoulder. Friction stir welding is so benefit, you know that, and that is some application using friction stir welding. There is a ship welding and offshore, aerospace, automotive, railway, robotics, personal computer, and for fabrication tool.
Thank you for watching our video. Please like and comment below at video.
Yes, I hope our video have some benefit for you. Good morning. Goodbye.
Bye.